All right, so today we're going to continue working on our mole unit, and we're going to kind of look at the mole a little bit different. So this lesson is going to build into empirical and molecular formulas. And so we're going to learn how to find percent composition or mass percent composition. So there are two ways of essentially saying the exact same thing. So the formula is really no different than how you would find a percent of anything. So again, if we were in class, we could look at the percentage of sophomores versus juniors versus seniors. So if you think about it, what information would you need to solve that? Well, there's two pieces you would need to know. Total number of students in the class, and then however many of the population you're studying, whether it be sophomores, juniors, or seniors. So when you take a look at a compound, if you're trying to obtain a certain element from a compound, you would most likely want to work with something that contains a lot of that specific element, where it makes up the majority. So the formula is that mass percent composition, and a lot of times, like I said, I just call it percent composition. You need to know two things. You need to know out of that specific compound, how much of that element that you're studying, like if it was water, what percentage of it is made out of hydrogen versus what percentage of it is made out of oxygen, divided by the molar mass of the compound. So we're using a skill we've built on and applying it into an equation. So I have two examples that we're going to work through today. The first one is talking about nitrogen or dinitrogen monoxide, also known as laughing gas, which is an anesthetic used in a lot of times with dentistry. So it wants to know what's the mass percent. So what we're going to do is figure out two things. What percentage of the compound is nitrogen and what percentage of the compound is oxygen. So to start here, the first thing that you want to do in this problem is calculate the actual molar mass of the compound. So we have NO2, or N2O, I keep mixing that up, N2O. So when we list it out, we have nitrogen and oxygen. We have two nitrogens and only one oxygen. So we're going to utilize our periodic table to find their individual masses. Nitrogen is 14.01 and oxygen is 16. So we can multiply and again add it up for a grand total molar mass of 44.02 grams per mole. So the next step is going to be kind of two calculations, and that's going to be figuring out what percentage of the compound is nitrogen and what percentage is oxygen. So the first thing I do when I set up this next part, it's using this formula up above. So I usually label it with what it is instead of just writing percent, because you're going to have more than one element that you're solving for. So in this case, it's the nitrogen. And so what you need is the mass of the element. Now it means the total mass of that specific element in the formula. The thing that's nice by doing your molar mass first is you kind of have that information. So that's going to be the numerator of my formula. So I take 2 times the molar mass of 14.01 gram per mole over the total molar mass of the compound, which is 44.02 grams per mole. The last step is we want to figure out what percentage it is. So you're going to multiply that by 100. So a couple things with that is for units, gram per mole divided by gram per mole is going to cancel. So mathematically what you're going to do to solve is you're going to take 2 times 14.01, then divide that by 44.02. I would then hit enter, and then you want to multiply it by 100. A lot of times you guys want to put percent in on your calculator. Do not put the percentage in. That is a unit. So to do that last part, you're going to literally just type in times 100. You do not put in a percentage sign. So when you do that, you get approximately 63.65% of this compound is made out of nitrogen. And like my mole calculations, I like to include what it is. There are two ways to do the remaining part. We need to figure out of the compound what percentage is oxygen. So the first way I'm going to show you is by showing our work. So to figure out what percentage of this compound is oxygen, we use its information. So oxygen is one of them out of the compound. There's one atom of oxygen. times its molar mass of 16 over its grand total molar mass of 44.02 times 100. Much like the previous calculation, grams per mole is going to eliminate. So you're essentially taking 16 divided by 44.02, timesing that by 100. Again, you do not type the percentage sign in on your calculator. So again, I would recommend as you watch these videos, pause it, run it through on your calculator, so that way you're ensuring that you're doing it correctly. And you get an answer of 36.35% oxygen. Okay? There is a separate way that you can solve this. Think about a percentage. What do all percentages add up to? They all add up to 100. So we knew 63.65% of the compound is nitrogen, and they have to add up to 100. So if you take 100% minus the percentage of the nitrogen, the 63.65, you would also get 36.35. Because again, those two elements should add up to 100. That's again another way you can check your work, is when you add these two up, they should be close to 100%. Now, sometimes due to rounding, you might get somewhere between 99 to 101% for your grand percentage total. Again, that's just due to rounding. So we have one more example that talks about where the odor of pears comes from. And so that's from a compound called propyl acetate, and its formula is C5H10O2, and it wants to know mass percentage composition. So we're figuring out of this compound what percentage of it is carbon, hydrogen, and oxygen. Again, what makes it much easier on you is to find the molar mass first. So we have carbon, hydrogen, oxygen. There are 5 carbon, 10 hydrogen, 2 oxygen. Carbon's molar mass is 12.01. Hydrogen will use 1, and oxygen is 16. Again, here we're going to multiply and add it up. I get a grand total mass of 102.05 gram per mole. So in this particular example, we're going to have 3 things to solve for. So I'm just going to start with the first one that's listed in the compound, and that's to figure out what percentage of it is carbon. Again, to do that, you take the total of that particular element. So we have 5 carbons, and they each have a molar mass of 12.01. I'm going to divide that by the grand total molar mass of 102.05. Times by 100. Those cancel, and so when I divide or multiply first, then divide it out, you get approximately 58.84% of this compound is carbon. Our next part we can work on is figuring out our percent hydrogen. We have 10 hydrogens, and the total molar mass will not change. So the only thing that changes as you solve these from element to element in a specific example is the numerator, the top part. And we're multiplying by 100. So when you set that up to solve, I got an answer of 9.80. So hydrogen is a very small component of this material, of this compound. Yes, there's 10 of them, but individually mass-wise, it contributes very, very little. So the last part I'm going to try to squeeze in here on the corner of my screen, and that's working out what percentage of it is oxygen. Now in the last example, I did the subtraction. So you have to know, like in the first example, there's 2 elements, so you need to know 1 in order to be able to solve the other if you use that subtraction method like I have over here starred with the orange. In this last example, because there are 3, you need to be able to know 2 of the 3. So you have 2 options here. You can take 100% minus the 58.84 and minus the 9.80. That's one way. If you want to set it up as an example like we've done, you would take 2 times 16 over that 102. And times 100%. So I got an answer there of 31.36. % oxygen. If you did the subtraction method, that way works out as well. So the rest of the examples you have 3 of them, the MgF2, the CaOH2, and the NH4,3PO4. So for each of those, you're going to find the % composition of each individual element in the formula. If you have any questions, concerns, please reach out to me.